algebra students, this is our introduction video for our lesson on understanding decay. Before we talk about decay and what that is, I want to review the different types of relationships we've seen so far in algebra. The first part of algebra, we spent a lot of time talking about linear relationships, and we saw you can have situations that are linear where the numbers are increasing. On a graph, it might look something like this, where you're adding the same amount every single time. That was a really big part of being linear. We also have seen situations where something is decreasing by the same amount. So it's still a linear relationship. It would still be a straight line, but every single time it decreases by the same amount. That would be a linear relationship where those numbers get smaller. In this unit, we've talked about exponential relationships, and we have seen exponential relationships are these relationships with multiplication. So in a situation where the numbers are increasing, but not by the same amount, but are increasing by the same factor, the same multiplication pattern, you have a relationship with exponential growth. And lots of times we've described that with those words, exponential growth. And in past lessons, we've seen it looks something like this, where you've got that curve where you're not increasing by the same amount, you're not adding the same number, but maybe you are multiplying by the same amount, and so that gives you that curved graph. We've only talked about exponential growth, but there are situations where instead of increasing and those numbers getting bigger, numbers can decrease in an exponential way. So different from what we saw with linear relationships where you're subtracting the same amount, you can have numbers that get smaller, not the same amount though each time, but using an exponential pattern. Now we've learned exponential patterns always use multiplication. So there's a way to use multiplication to get numbers to go down in that exponential pattern. So one of the things we're going to explore in these next two lessons is what would that graph look like? I know it's not going to look like this because these numbers get bigger. We know it should be decreasing, but it's not going to decrease in a straight line. So maybe you're wondering, would it decrease like this? Would it decrease like this? Would it decrease like this? That's one of the things we are going to learn in these next two lessons is what that graph looks like. What I really want to talk about, though, is how can you use multiplication to make numbers get smaller? And to help us have that conversation, we're going to look at this story here. We've got each time you fold a piece of paper, the area is half as big as it was before the fold. So for example, before we fold the paper at all, 0 folds have happened. Maybe you have your area is 100. Now, if you're like me, I see the area as half as big. So after one fold, I might be thinking, well, 100 divided by 2, that gives me an area that's half as big. I immediately think division, but in this unit, because we're going to be talking about exponential relationships, there's a way to do this instead of using division with multiplication. Any idea what that multiplication would be? If we want an area that is half as big, that means you can multiply by 1/2. 100 multiplied by 1/2 gives you that 50 right there. And so I've just made a number smaller using multiplication. The key is going to be if you multiply by a number less than 1. That is how you get those numbers to decrease. So something like 1/2, 2/3, 0.1, those are all numbers that are less than 1, and when you multiply by those numbers, it makes the numbers go down. And so for that first fold, I can say, and I'm going to move this over, 100 times 1/2, that gives me that area of 50. After 2 folds, we're going to keep that pattern going. So what do you think I need to do for my second fold? What math? Well, after the second fold, we're just going to keep continuing that pattern. It's going to be half as big, and so 50 times 1/2 is 25. You could do it that way, 50 times 1/2, or you could say we're starting with an area of 100, and when I fold it in half twice, it means I need half of that first area, and then half of that second area, and think of it this way as well. Go ahead, pause the video, and try figuring out what your third and your fourth fold, the area would be. For your third fold, you could take your 25 and multiply it by 1/2, and that would give you 12.5. You could also take that 100 and multiply it by 1/2 times 1/2 times 1/2. Now, I could write 1/2 times 1/2 times 1/2, or I could just write 1/2. You remember what it's going to be? And use that exponent, that cubed right there, 1/2 cubed, which would mean 1/2 times 1/2 times 1/2 to get that answer. And then for that final one, for our fourth fold, if I only needed the answer, I could just do 12.5 times 1/2. That's going to be 6.25 when you multiply that number by 1/2. Or again, we could write out the full math problem. We're starting with an area of 100, and I would have to fold it in half 4 times to get there. The focus of the first part of this lesson is really going to be on these tables, but in these next 2 lessons, we're going to talk more about the graph above and what would it look like if I were to graph this situation, as well as the equation for this situation. The focus of these next 2 lessons, though, are going to be on situations like these, where something is decreasing using multiplication. And you may have noticed for the name of this lesson, we call this right here exponential decay, when their numbers are getting smaller using that multiplication pattern. So today and tomorrow are going to be all about exponential decay. What do these tables look like, these graphs look like, and these equations. You are ready for today's lesson. Thanks so much for watching.